Dear students, welcome to Abhi online classes. Today we'll discuss how to find eigenvalues and eigenvectors of a 2 by 2 matrix in the chapter Eigenvalues and Eigenvectors. We'll see one problem. Determine the eigenvalues and eigenvectors of the matrix 2 by 2 matrix A equal to 5, 4, 1, 2. Now we'll see first how to find eigenvalues. Characteristic roots. Given A is equal to 5, 4, 1, 2. This is a 2 by 2 matrix. First we find out characteristic equation of this matrix. Characteristic equation of A is given by det A minus lambda I equal to 0. This is the characteristic equation. Det 5 minus lambda 4 1 2 minus lambda is equal to 0. To find the characteristic equation of A, just it is enough in this det we subtract lambda from the principal diagonal elements. Just we subtract lambda from the principal diagonal elements of A, will get det of A minus lambda I. Now we expand this det. AD minus BC. 5 minus lambda into 2 minus lambda minus BC. 4 into 1, 4. Now we multiply. 2 into 5, 10 minus 2 lambda minus lambda into 5 minus 5 lambda minus lambda into minus lambda plus lambda square minus 4 equal to 0. Lambda square minus 7 lambda 10 minus 4 plus 6. This is a quadratic equation in lambda, second degree equation. This equation also we can call it as a characteristic equation of A. This is the characteristic polynomial and this is the characteristic equation. Now we find out the values of lambda. 1 into 6 equal to 6. So 1 plus 6 anyhow 7. No? So lambda square minus 6 lambda plus 6 equal to 0. We write this minus 7 lambda as minus lambda minus 6 lambda. Take lambda as common. Take minus 6 as common. Again lambda minus 1 common. Lambda minus 6. So we got lambda minus 1 equal to 0 or lambda minus 6 equal to 0. Lambda is equal to 1, lambda is equal to 6. Therefore, characteristic roots of A, eigenvalues also we can call it. Characteristic roots of A are 1 and 6. So, in the competitive exams, they used to ask us to find out a characteristic polynomial or characteristic equation or characteristic roots of A. This is the procedure to find out characteristic roots of A. We call 1 as lambda 1 and 6 as lambda 2. Now we find out characteristic vectors of A corresponding to these characteristic roots. The characteristic vector x1, we take this as x1 comma x2 of A corresponding to lambda 1 equal to 1. Corresponding, we got two characteristic values. First we take lambda 1, 1. The characteristic vector of A corresponding to characteristic root lambda 1 equal to 1 or is given by non-zero solutions of the equation A minus lambda I into x equal to null matrix. Now we find out characteristic vector using this equation. A minus lambda I, 5 minus lambda 4, 1, 2 minus lambda, A minus lambda I, this is, and capital X is x1 comma x2 equal to null matrix. We write it as 0, 0. Now we put lambda 1 here. For the first characteristic root, we are finding the characteristic vector. Now we replace lambda 1 by 1. 5 minus 1, 4, 1, 2 minus 1, x1, x2 equal to 0, 0. 4, 4, 1, 1. x1, x2, 0, 0. Now we apply a row transformation. R2 implies 4R2 minus R1. On applying this transformation, first row as it is, and the second row will become 4 into 1, 4 minus 4, 0. In the same way, 4 into 4 minus 4, 0. Therefore, rank of this coefficient matrix is 1 because it has only one non-zero row by echelon form. By echelon form, it has only one non-zero row. This is a 0 row, no? Number of non-zero rows, only 1. By echelon form, we are finding the rank of this coefficient matrix. Therefore, R is equal to 1. Therefore, number of linearly independent solutions is equal to n minus r. Number of variables 2 and rank is 1. So we are getting only one linearly independent solution. That one linearly independent solution is given by 4x1 plus 4x2 equal to 0. Therefore 4x1 equal to minus 4x2. Cancel 4. x1 by 1 is equal to x2 by minus 1. We can write this also as x1 by minus 1 equal to x2 by 1. We can write this also like that. Therefore, capital X is equal to x1 comma x2, that is 1 minus 1. This is the characteristic vector. Is the characteristic vector of A. Eigenvector also we can call it as. This is the characteristic vector of A corresponding to characteristic root or eigenvalue. Characteristic root lambda 1 is equal to 1. This is the procedure to find out the characteristic vector corresponding to characteristic root of A. Briefly, I will explain once again. The characteristic vector corresponding to the characteristic root of A is given by the non-zero solutions of the equation A minus lambda I into X is equal to null matrix. We are taking the first characteristic root, that is why I have written lambda 1. So A minus lambda 1 I as 5 minus lambda 1, 4, 1, 2 minus lambda 1. Capital X is x1, x2 and the null matrix is replaced by 0, 0. Lambda 1 is replaced by 1. 5 minus 1, 4, 4, 1, 1. So we are changing this into echelon form by applying the row transformation. R2 implies 4R2 minus R1. So we got 1 0 row and 1 non-zero row. Number of non-zero rows in this quotient matrix is 1. Therefore, rank of this quotient matrix is 1. We have only one non-zero row. Number of linearly independent solutions is given by n minus r. N means number of variables and r is the rank of the quotient matrix. Number of the variables is 2. So 2 minus rank is 1. 2 minus 1 is 1. That means we are getting only one linearly independent solution. That solution is given by 4x1 plus 4x2 equal to 0. Therefore 4x1 equal to minus 4x2. Cancel 4 on both sides. We can write this as x1 by 1 equal to x2 by minus 1. Therefore capital X is equal to x1, x2. 1 minus 1. This is the characteristic vector of A corresponding to the characteristic root lambda 1 equal to 1. Find the characteristic vector x2, x1 comma x2 of A corresponding to lambda 2 equal to 6 is given by non-zero solutions of the equation A minus lambda I into X equal to null matrix. I write here lambda 2 and this is x2. Previously we write this x as x1. Okay. Now A minus lambda 2 into x2 equal to null matrix. 5 minus lambda 2, 4, 1, 2 minus lambda 2. Capital X2 is x1, x2, and the null matrix is 0, 0. Now I write this lambda 2 as 6. Second characteristic root, 5 minus 6, 4, 1, 2 minus 6, x1, x2. This is equal to null matrix 0, 0. Minus 1, 4, 1 minus 4. Now we apply the row transformation. R2 implies R2 plus R1. I am changing this into upper triangular form, echelon form. By using the echelon form, I want to find out the rank of this coefficient matrix. That's why we are applying the row transformation. R2 implies R2 plus R1. Minus 1, 4. First row same. Second row is changing. R2 plus R1. Minus 1 plus 1, 0. Minus 4 plus 4, 0. Therefore, number of non-zero rows in this coefficient matrix is 1. Therefore, rank of coefficient matrix is 1, that is R. And the number of linearly independent solutions is given by n minus R. Number of variables 2. N is number of variables and R is rank. 2 minus 1, 1. Therefore, we are getting only one linearly independent solution. The solution is minus 1 into x1 minus x1 plus 4 into x2 4x2 equal to 0. Minus x1 equal to minus 4x2. Cancel minus on both sides. X1 by 4. We bring this 4 here. And x2 by 1. Therefore, capital X is equal to x1 comma x1 x2. That is 4 comma 1. 4 1. Is the characteristic vector of A corresponding to characteristic root lambda 2 equal to 6. Therefore, the characteristic vector x2 4 comma 1 is the characteristic vector of A corresponding to the characteristic root lambda 2 equal to 6. This is the procedure to find out characteristic roots and the characteristic vectors for the 2 by 2 matrix. In the next session, we will discuss how to find out characteristic values and characteristic vectors for the 3 by 3 matrix. Hope you understood this class. Thank you.